Welcome back, ladies and gentlemen. The last video got cut off halfway because I had something to do and I had to go out. And this will be the continuation for factors and polynomial. So, as a continuation of what we were doing in the last video, given that px has a remainder of 2 when divided by 2x plus 1 and qx is divisible by x plus 2, find the value of each of the constant a and b. Now, what this part here basically says that when px has a remainder of 2 is divided by 2x plus 1, right? So it simply means from here, x is equals to negative 1 over 2. And when you substitute x into this equation here, you would get an equation that equals to 2, okay? So let's try putting that in. 2 to the power of 1 over 2 to the power of 3 plus 5 and negative 1 over 2 square plus 4, negative 1 over 2 here, plus a, this will equals to 2. Okay, this is for px. And the same thing for qx, then you would have over here, x is equals to negative 2, 4 bracket negative 2 square plus 3a bracket negative 2 plus b. Now, if you substituted negative 2 into this, then since it's divisible, it will equals to 0. From here, we can actually see that we will be able to solve for a on the left-hand side's equation. Simplifying what we have here, this will then turn into negative 1 over 4 plus 5 over 4 minus 2 plus a equals to 2. Okay, then this will just give you 1 minus 2 negative 1 bring over. Okay, let's do it like this instead. Negative 1 plus a equals to 2, and therefore a will equals to 3. Okay, since we found that a equals to 3, we are going to substitute this into our next equation here. This will be 16 plus 3a multiplied by negative 2 plus b equals to 0, and therefore be able to solve b here. 16, 9 times negative 2, negative 18, okay, plus b is equals to 0. Negative 2 plus b equals to 0. b will therefore just equals to 2. And there you have it, solving the constants for a and b. Okay. In this next part here, it's related to the first question. So given that Rx is equals to Px minus Qx, using your values of A, B, find the exact remainder of Rx when Rx is divided by 3x minus 2. Okay, so what we're supposed to do is we're supposed to substitute our equations for Px, which is 2x cubed plus 5x squared plus with 4x plus 3 equals to, sorry, this is px minus qx, which was 4x squared plus 3 times 2 is 6, sorry, 3 times 3 is 9, 9x plus 2, okay? This will therefore equals to Rx, okay? First, we figure out how much is this first. Rx will be equals to 2x cubed, 5x squared minus 4x squared. You're left with plus x squared. 4x minus 9x will be minus 5x. 3 minus 2 plus 1. Okay, this is the equation for Rx. Find the exact remainder. So we're going to use this divided by this using the long division method. Oh, okay, actually, instead of using the long division method, I think we'll just use the substitution method. So x actually equals to 2 over 3. Okay, 2 over 3. Substitute it into this equation here. 2 over 3 cubed plus 2 over 3 square minus 5 times 2 over 3 plus 1. This will be R2 over 3, like so. Okay. simplifying this equation, I'm going to use the calculator. 2 over 3 to the power of 3 times 2 plus with 4 over 9 minus 10 over 3 plus 1. You would end up with a factor that is a fraction. In this case, the remainder would have been negative 35 over 27. Okay, negative 35 over 27. Next question here. Use the factor theorem to show that 2x minus 1 is a factor of px, where px is equal to 4x cubed plus 9x minus 5. Use the factor theorem, meaning to say we're going to substitute this into the equation here. In this case here, since they've specified, you have to do what they say. X is equal to 1 over 2. Substitute it into the equation. 4, 1 over 2 cubed plus 9, 1 over 2, and then minus 5. In this case here, calculating this, typing this into your calculator, okay, you would end up getting 0. Therefore, proving that 2x minus 1 is a factor of 4x cubed plus 9x minus 5. 1 mark question. Okay. Now, the next question over here, write px as the product of linear and quadratic factors. So we already have our linear factor, which is 2x minus 1 here. Okay. And to get the quadratic factor, what we need to do is we need to use long division method. So we need to use 4x cubed. Now, what you can see here is they actually skipped 1x to the power of 2 here, okay? Meaning to say it's actually 0x squared, right? But for the long division method, you need to actually write it down, okay? 0x squared. Then only do you move on to the next x plus 9x, okay, and minus 5. And only through this method of including the 0x squared here, can you do your long division method of dividing it with 2x minus 1 as stated as the factor here, okay? From here, just doing it the normal long division method, 2x squared, you will get 4x cubed minus 2x squared, okay? This minus this minus minus, okay? Always put a bracket outside so that you can remember to minus minus. You would now with 2x squared plus 9x, then plus just x here, where you would get 2x squared minus x, okay? Then again, minus minus this eliminates this minus minus x, you will get 10x, bring the 5 down. Then lastly, finish off your division. This will be plus 5, okay? Times 5 with 2x minus 1, 10x minus 5, okay? And therefore, you would have your quadratic factor here and your linear factor. All you have to do is rewrite your equation. Px is equals to 2x minus 1 and 2x squared plus x plus 5. Your linear and your quadratic factor, like so. Okay. One last example for this chapter here. Given that x minus 2 is a factor of this cubic equation here, use the factor theorem to show that a equals to 4. So instead of proving it like what we did was it's a factor, we want to find a using your factor theorem. So no difference. In here, just find x equals to 2 from this part here. Okay, substitute it into your equation. A 2 cubed minus 12, 2 squared plus 5, 2 plus 6. This is equals to 0. Okay, calculating this, 8a minus 4 times 2, 12, 48 plus 10 plus 6 equals to 0. 8a would therefore equals to negative 48 plus 10 plus 6 equals to 32, because this adds up to negative 32. Bring it over, becomes positive 32. A would finally equals to 32 over 8. 4. Okay, A equals to 4 as shown in your question here. If you guys don't get the same answer, that means you've done something wrong with your working, and I would recommend you to redo the whole thing. All right. Now, lastly, looking at this last question here, showing all your working, factorize 4x cubed minus 12x squared plus 5x plus 6, and hence solve this equation here. First of all, we know that this quadratic equation, this cubic equation can be factorized by x minus 2, okay? We're going to use long division method and divide that first. Right, x plus 6, okay, divide this with x minus 2, get 4x cubed, you have to use 4x squared times with this, 4x squared times with this, you will get 4x cubed minus 8x squared, okay? Then remember it's minus minus, so negative 12 minus 8x squared, you would end up getting minus 4x squared plus 5x. So in this case here, the same thing, you would have minus 4x here, minus 4x times this, you get minus 4x squared plus 8x over this, and minus minus again, you would end up with 5 minus 8, negative 3x plus 6. So in this case here, you would have minus 3 times this, minus 3x plus 6, completely factorized, okay? So in this case, you would have as a quadratic factor and a linear factor, px is equals to x minus 2 and 4x squared minus 4x minus 3, okay? 4x squared, oh sorry, this is not px, just leave it, maybe you can just, yeah, leave it as px, should be fine, okay? Then in this case here, I think you should still factorize this. So what you can do is you can type it into your calculator and see can it be completely factorized. In our case, that would be a no. Wait, yes, it can, okay? This will therefore again be factorized to 3, sorry, not 3. It shouldn't be 3. It should be 2x minus 3 and 2x plus 1, okay? This will be completely factorizing the quadratic equation here and leaving all your answers in linear form. Now, from here, what we're going to do is we would therefore have to solve the quadratic equation, sorry, not the quadratic, to solve this cubic equation here, then x would equals to 2. In this case here, x would equals to 3 over 2. And in this case here, x would equals to negative 1 over 2. Therefore, solving the equation here. Okay, and that will be it for factors and polynomials. Hope the video helped you guys. Thanks.